Hello everybody. In this video, we're going to be dealing with double angle identities, but we're also going to have to know what compound angles are. So before you continue with this video, it's mostly going to consist of compound angle understanding, and it'll be a waste to just go over compound angles again when there's already a video on this. So I would recommend going back to that one before you get into this. Okay. So double angle identities, it has its own identities, but you usually prove them using compound angles, okay? So let's look at the first one, right? Let's look at the one with sine. Okay, so we're first going to say here, what is the double angle, okay? The double angle would be 2 theta, because we are doubling the angle, if it's not straightforward enough. But we know that sine of 2 theta, if something is doubled, such as let's say 3 multiplied by 4, we can actually write this as 4. Well, that is not a double, by the way. 2 times 4 can be written as 4 plus 4, okay? Because that just means we're doubling something, meaning that 2 theta can be written as theta plus theta, okay? Because at the end of the day, you could always just take out the common factor of 2, and then you'll be left with 1 plus... What am I doing? You can always take out the common factor of theta, and then you'll have 1 plus 1 left over, which is basically theta times 2, which is the same as 2 theta, okay? So I'll just leave this here, okay? Important. So sine of theta plus theta, we can write this in compound angle form. Notice that this is the same as A plus B. Notice we still have theta and theta, but let's still treat it as if it was compound angles, okay? So this is sine, meaning we are going to have sine cos, cos sine. So it's going to be sine theta, cos theta, plus, because it's plus, we're going to choose plus on this side, and then cos theta, sine theta. Okay. Notice that what we can do is say that sine theta, cos theta is the same as cos theta, sine theta, because what can we do? We can just do this. We can just swap this order around. So it's sine theta, cos theta. Then notice that because we have 2 of them, this will just be 2 sine theta, cos theta. And there we go. This is going to be the double angle of sine, okay, which is 2 sine theta, cos theta. Now let's do the one with cosine, okay? So if we have cosine of 2 theta, then notice we can write it as cos of theta plus theta, okay? And then the compound angles for cos is just cos, cos, sine, sine. And if we're choosing a positive on one side, we have to choose the negative on the other side, okay? So it'll be cos theta, minus sine theta, okay? Cos, cos, sine, sine. This is just the same as cos squared theta minus sine squared theta. And there we go. We've got one of the identities. And yes, I did say one of the identities. This can actually be rewritten in 2 other forms. How do we rewrite this in 2 other forms? So I'm going to say therefore over here. So this is the first one, okay? The other form that we could use is literally by taking the cos squared theta and using the identity that says sine squared theta plus cos squared theta is equal to 1, we can actually manipulate it in a way where we can let sine squared theta be the subject of the formula, and then it's equal to 1 minus cos squared theta. And then we can take the other one that says cos squared theta is the subject of the formula, and then we just have 1 minus sine squared theta, okay? So all we're going to do is, let's do the first one where we replace cos squared theta, okay? So for this one, let me rather do it in another line over here. So cos 2 theta can be the same over here as cos squared theta, which is the same as 1 minus sine squared theta, okay, minus sine squared theta. And then if we simplify this, notice that we are going to get 1 minus 2 sine squared theta, okay? So that's how we derive this one. So it's cos of 2 theta. And this one is the second method. The third method, which is the final method that we can use to get the other identity, is by replacing, so where's the original one here? is by replacing sine squared theta with 1 minus cos squared theta. So here we have cos squared theta minus 1 minus cos squared theta, okay? And then from here, we just simplify. Notice that we are going to get the negative cancels out here with this one. However, we still have a negative 1 or a minus 1. So we have 2 cos squared theta minus 1. And then cos of 2 theta. And that's the third part of the identity. Okay, so that's how you prove them. Okay, let me write them all down for you just so we have a summarized version. And here we go. Here's the summarized version. So we have the double angle for sine, and then we also have the double angle for cosine, where we have 3 potential variations. So when it comes to proving with trigonometry or simplifying, usually you need to look out for these patterns. And that is what makes this amazing, is if you know how to manipulate one of them, then you should have it easy for the other two. Okay, so let's get into our first example over here now. So here is our first example that we have here. Okay, so we need to simplify 2 multiplied by sine theta cos theta, and then we need to divide it by 1. Well, we don't need to do that, but it is divided by 1 minus 2 sine squared theta into a single trig ratio. So first things first, what can we do? Well, there's 2 ways, and the first one is the easiest one. The first way, we can just take this into the fraction, okay? In some cases, you might not be given this 2. So let's actually go into an instance where, let's say, for example, you didn't have this 2, okay? Just for now. We'll keep the 2 on the side, but let's just go into an instance if we didn't have the 2. Sine theta cos theta. How do we actually get that in terms of double angle here? Because we want it in a single trig ratio. So if we notice, remember that sine 2 theta is the same as 2 sine theta cos theta, okay? But also, notice that sine theta cos theta is over here, okay? So meaning we can actually just half both sides, such that we get a half sine 2 theta, which is equal to sine theta cos theta, okay? I know this is very unnecessary for this type of question. However, I do want to show you in the case of maybe you didn't have the 2, okay? So that you're well prepared. Therefore, this sine theta cos theta is just equal to a half sine 2 theta. So see, it's a half sine 2 theta. And this is all divided by 1 minus 2 sine squared theta, which is just equal to cos 2 theta. Remember, that's the double angle for cos, one of them. Notice that we can take a half out so that we have 2 over 2. And then we have sine 2 theta divided by cos 2 theta. And the 2's can cancel out, and then we just left with sine 2 theta over cos 2 theta, which we can write as tan 2 theta. And there we go. We just did it into one single trig ratio. So just be careful in case you see something this similar. And then you can obviously just be prepared the next time. Okay. So let me get rid of this red cross quickly. Okay, let's go to the next example. Alrighty, so we have this question right now. Okay, we need to evaluate 1 minus sine square of 30 degrees over 2 cos square of 15 degrees minus 1. Okay, so first things first, you probably look at the numerator and say, oh, that's a cos double angle. Well, unfortunately, you are wrong. Why? Because it's missing a 2. So we can't actually use a cos double angle on the top. However, the bottom is 2 cos square 15 degrees minus 1. So that is a double angle because it has the 2 in front of the cos is first, and it has a square, and it's minus 1. Okay, so let's just rewrite it like this. So we're still going to keep it as 1 minus sine square of 30 degrees. Okay, so in this case here, what else are we going to have? We have 2 cos square. So we know that this is a double angle. Okay, so meaning it's going to be cos 2 of 15 degrees, right? Because 15 degrees is what's inside, and remember it's a double angle, so it's cos 2 times 15 degrees, And then notice that we have 1 minus sine square of 30 degrees, square of 30 degrees, divided by cos of 30 degrees. Okay, because we can multiply the 2 into the 15. Cool. Now what? So in this case over here, notice that 1 minus sine squared 30, we can actually get another variation of this. Notice we can use that one identity that tells us that 1 minus sine square of theta is equal to cos squared theta, right? If you remember the other identity. So therefore, this is actually just going to be cos square of 30 degrees divided by cos of 30 degrees. And notice, because the top is being squared, we can cancel one of them out with the bottom. And then therefore, we're left with cos of 30 degrees. And cos of 30 degrees is just going to be equal to the square root of 3 over 2. Okay. Cool. So that is the answer to this question here. Okay. So here's our question. Example 3 says, evaluate sine of 22.5 degrees. So this is another type of question which is actually easier than it looks. So this one is very interesting because we see a decimal, first of all. What on earth are we going to do? And this is without a calculator, by the way. We can't use a calculator. Otherwise, you'll be executed. Okay. So anyway, don't pay too much attention to that one. Evaluate sine of 22.5 degrees. Okay. So first things first, what on earth is going on here? If we analyze this value, notice that if we double this value, we get 45 degrees. Now we do know what sine of 45 degrees is. That is 1 over root 2. However, how on earth are we going to get to a point where we can evaluate this? So we need to cycle through our double angles because clearly it has something to do with doubling this value. But the thing is, how do we get to that point? Let's cycle through them quickly. So if we're looking at the double angle of sine, right? Let's look at the double angle for this one would be 45 degrees. The reason why I'm saying 45 degrees is because it's 2 times 22.5. So this is the double angle, okay? The double angle over here, and then the other side is the other side. So double angle of sine is just going to be 2 times sine of 22.5 degrees times cos of 22.5. Remember that the angles on the other side is half the one on this side, okay? But there's a problem. We know what this value, well, we actually know sine of 22.5 is here. We don't know what it is exactly. However, what about this now? It's giving us more problems. So which means we can't use this part over here. Let's try the cosine of 45 degrees. So the double angle of cosine, okay? Which double angle of cosine only has sine? Well, it's going to be 1 minus 2 sine squared of 22.5, right? So doesn't that actually make it much easier? Because we know what cos of 45 degrees is. It is 1 over root 2. But we don't know exactly what is sine of 22.5, which clearly the square is going to go out. So this might actually just work. So we can say over here, this sine of 22.5 degrees, so let me write it here just to make it look neater. Sine of 22.5 degrees. Wait, we can't really do that one though. We need to say use cosine double angle, okay? Such that what we're going to have is cos of 45 degrees is going to be equal to 1 minus 2 sine squared of 22.5 degrees, okay? And then from here, notice we have 1 minus 2 multiplied by sine of 22.5 degrees raised to the power of 2. And we know that cosine of 45 degrees is equal to 1 over root 2, right? Using the special triangle. And then over here, 1 over root 2 is just going to be equal to, and then let's look at the right hand side, okay? We need to get this on its own, okay? Because we know everything else is just a number. However, sine 22.5, we don't know exactly what that is. So we need to get it on its own, as if we were solving for x, okay? So if you wanted to make it easier for yourself, you can let x be equal to sine 22.5, and then you can solve for x as it is, which we are most probably going to do. You can do it if you want to, but for this video, I won't, okay? So here, we can take the 1 over to the other side, so that we have minus 1, and then we are left with negative 2 times sine of 22.5 degrees squared, okay? And then we can multiply both sides by negative, okay, so that we don't have to deal with the whole negative problem with the square roots. So over here, we multiply both sides by negative, and then what are we going to be left with? We are going to be left with 2 sine 22.5 degrees, and this is all squared, and then this is just equal to 1 minus 1 over root 2, and then we can get this part on its own, so that we have sine of 22.5 degrees squared, which is equal to, we divide both sides by 2, such that what we have is we are going to have 1 over 2 minus 1 over 2 root 2, okay? Otherwise, you could always just say a half multiplied by this part. Okay. Now, we can take the square root on both sides, okay? Then what we will have is sine of 22.5 degrees on its own, which is equal to plus or minus the square root of, you can just, you can either write this as one fraction or not. For this one, I'm going to write it as one fraction, meaning this would be written as the square root of 2 minus 1 over 2 root 2. So then we have it looking like that, okay? Okay, now, here's the thing. Are we going to choose the positive or the negative? Think about this, right? Sine of 22.5 degrees. 22.5 degrees is in which quadrant? It's in the first quadrant. And we know that in the first quadrant, everything is positive. Therefore, the answer here has to be positive. So, therefore, you can say since 22.5 degrees lies in quadrant 1, this implies to us that sine of 22.5 degrees is equal to the square root of 2 minus 1 over 2 root 2. There we go. And that would be the final answer for this one.